All right, so we're reviewing the different flip-flops, and the D flip-flop, the output is the same as the input. The reason you use a D flip-flop is for the timing, not because of what it does to the signal. The signal is going to be the same. So for the characteristic table, what you have, as long as, so if we look at this flip-flop, this is a positive edge triggered. And we know it's positive edge triggered because if you look at the little triangle right here, there's no circle. A little bubble right there tells you it's negative edge triggered. So what that means is it only changes once every clock cycle, and it does it when the clock goes from low to high, so when it goes from 0 to 1. And then I'm going to put Q and Q star. So Q is what the current output is, and Q star is what the next output is. And so we have 4 possibilities here with our input D and Q. And you'll see that the next value of Q depends only on what D is. So Q next is going to be 0 whenever D is 0, and Q next is going to be 1 whenever Q is 1. And this change happens, so you only change on the positive edge of the clock.
For Q star, is it okay if we put Q bar?
Well, it's not Q bar, because Q bar is the opposite of Q. So this is the same, so I could also do it like Q new, or Q next, or something. Sometimes they do it like Q of T, and then Q of T plus 1. Okay, but it is different from Q bar. Although I see there is the Q bar on the flip-flop, but it's not, but that's not what this one is referring to. So Q bar is always just going to be the opposite of Q. Okay, now this next one is a negative edge triggered. So change only happens when clock goes from high to low. However, what it does is the same. It's still true that Q follows D, which means that Q Q becomes whatever D is, and it doesn't matter what the last value of Q was, and so our characteristic table is going to look the same. I'll put Q next here. 0, 0, 1, 1, 0, 1, 0, 1. And so Q next, the next value of Q will be whatever D is.
For the positive edge trigger, you said for the D flip-flop, it changes and it goes from low to high, right?
Correct.
Okay.
So if we're looking at the clock signal, so if this is the clock signal, then you're going to have positive edge trigger is going to happen here. So that'd be a positive edge, and the negative edge trigger is would happen here.
what does it say right next to only? Oh, for the negative edge trigger. You know what I'm talking about?
Only change.
Only change.
Yep. Now for a T flip-flop, the T stands for toggle. And that means that your next value of Q does depend on what the previous value of Q is, as long as T is 1. And so our description in words is going to be, if T equals 0, Q stays the same. If T equals 1, Q toggles. And by toggles, it means becomes the opposite of whatever it was. So when T is 0, Q star is the same as Q. It doesn't change, so Q remains the same. But when T is 1, then Q toggles and it becomes the complement of what it was before.
So the opposite.
The opposite.
Okay.
Notice this particular T flip-flop is also positive edge triggered. You can always tell if it has a bubble next to the triangle, then it's negative edge triggered, and if it doesn't, then it's positive edge triggered. Okay, so this next one is a JK flip-flop, and so we have two inputs, J and K. J is set and K is reset. And so here, because we have two flip-flops, two inputs, as well as whatever the value of Q is, we have 8 different possibilities. So I'll write my characteristic table over here. And in words, what we can say is if J and K are both 0, then there's no change. So that means Q next, or Q star, the next value of Q is the same as the previous value of Q. If J equals 1, and K equals 0, then that's a set and Q equals 1. Regardless of what Q was before. If J equals 0 and K equals 1, then Q equals 0, that's a reset, regardless of what Q was before. If J equals 1 and K equals 1, then Q toggles. So for these first two, J and K are both 0. So when J and K are both 0, we have no change, so Q star is the same as Q. If K is 1 and J is 0, like we have in our next two, then Q equals 0. If J is 1 and K is 0, then our next value of Q is going to be 1. And if J and K are both 1, then Q toggles. So when Q was 0, it becomes 1, and when Q was 1, it becomes 0. Alright, so that was just your brief review of what the different flip-flops do, and now let's look at a timing diagram. So this says to plot the Q output of a positive edge-triggered T flip-flop given the inputs below. Assume that Q is initially 0. So I'm going to have my Q output right here. Assume that Q is initially 1. So Q starts at 1. Now it says it's positive edge triggered, so what I like to do is locate the positive edges, and I know that I can only change at the positive edge. And so I'm going to draw lines at my positive edges. So positive edge, that's not a, is when it goes from 0 to 1. So it can only change there. And so Q starts at 1. And when I get to this first positive edge, the flip-flop will look and see, well, what is the value of T? Well, the low is 0, high is 1. When we get to this first positive edge, T is 0. T being 0 means no change. So it's going to stay where it is until we get to the next positive edge. At the next positive edge, we look at T. We see that T is 1. That means we'll toggle. Toggle means Q is going to switch to the complement of what it was. It was 1. It'll become 0. And it'll stay 0 until we get to the next positive edge. When we get to the next positive edge, again we look at T. We see that it's 0. 0 means no change. So it'll stay where it is until the next positive edge. At the next positive edge, T is 1. That means we're going to complement, and Q was 0, and it will become 1. So if y'all have any questions, do make sure that you ask. Okay, for this next one, we have 3 flip-flops. Well, actually, we have 1 latch and 2 flip-flops. We know this top one is a latch because it just has clock and not a triangle. And so a latch, so this will be a gated latch. That means it can change as long as the clock is 1. So unlike the flip-flop that can only change once every clock cycle, if the clock is 1, it can change. Whenever the input changes, it changes. These flip-flops, they can only change once every clock cycle. This one can only change on the positive edge, and this one can only change on the negative edge. So I'm going to draw for my 3 flip-flops a QA, QB, and QC. And it says to assume that Q is initially 0. Now, I'm also going to draw lines to show where my clock edges are. I'm going to draw a red line for the positive edge. So all the positive edges will be red. And I will draw I'll do purple for the negative edge. Yes. So from the red to purple, that's when the clock is at 1, and from the purple to red, that's when the clock is at 0. So when I look at my first latch here, when I get to the first positive edge, this one can change as long as the clock is 1. So this top one can change throughout the entire clock cycle, well, not the entire clock cycle, just while it's 1. And because they're a D flip-flop, Q follows D. So Q is going to do exactly what D does. So when it gets to this positive edge, it can then change. And so it looks at D, it sees that D is 1, so it becomes 1. And then while we're still in this positive high, the clock is high, D goes back down to 0, and so does Q. And so Q follows D during the high portion of the clock cycle. And then during the low portion, it doesn't change. It can't change. And then when the clock is high again, it's going to do whatever D does. It'll follow Q follows D until it gets to the negative clock edge, and then it doesn't change. And then with the positive one, it will follow it until it gets to the negative edge, and then it doesn't change. And then with the positive one, again, it's going to do whatever D does. So that's what the latch looks like. This is not supposed to be lower than the other one. These are supposed to be. Okay, so QB is positive edge. So it starts at 0. When it gets to the positive edge, it looks to see what D is. D is 1, so it becomes 1. And it stays there until the entire next positive edge. Then when it gets to that next positive edge, it looks at the value of D. There D is 0, so it becomes 0. And it stays there until the next positive edge. At the next positive edge, D is still 0, so it stays 0. And at this last positive edge, D is 1, so it becomes 1. And for the last one, for the negative edge triggered, it says it starts at 0, so it's initially 0. It can't do anything till it gets to the negative edge. When it gets to the negative edge, it looks at D. D is 0, so it stays 0 till the next negative edge. At the next negative edge, it's still 0, so it stays 0. At the next negative edge, it's 1, so it becomes 1, and it stays there until the end. So any questions on that one? All right. Complete the timing diagram for the circuit below with positive edge triggered flip-flops. Assume Q1 and Q0 are initially 0. Okay, so for this one, so this is going to be a lot of what y'all are working with this semester is sequential circuits. So we have one flip-flop after the other. So let's start with Q1, which is this first one. So this Q1 is the output of the first flip-flop, and so it's going to be based on its input, which is Z. It's positive edge triggered, so it will change at, I don't know why I have negative edge drawn on there because it says positive edge triggered, so I'm interested in the positive edge. So when I get to this first positive edge, it'll look to see what Z is, and Z is 0. So it'll stay there until the next positive edge. And when I get to that positive edge, again, it'll look to see what it is. Oh, well, this is very boring. Oh, no, the next positive edge is 1. Okay. And then, so it'll stay there till the next positive edge. And at the next positive edge, Z is 1, so this becomes 1. And it will stay there until the next positive edge when it becomes 0 again. Now, the second flip-flop has as its input the output from the first flip-flop. So the second flip-flop is going to be looking at this output right here. So it starts at 0, and it has to remain 0 until it gets to this positive edge. And then at that positive edge, actually, it's really, we got to be a little careful here. Because this one wouldn't actually have changed immediately at the positive edge. It's going to take it a little bit of time. So when this one gets here, it doesn't see that this one has changed yet, because it's going to take a little bit of time for this one to change. So it's still going to see the 0 from the time before. So it's lagging one behind the one before it. So it's not actually going to change until it gets to the next positive edge, because it's going to be one behind, because it takes a little bit of time for it to change. I don't remember doing this example before. But we'll see more examples of sequential circuits. I think the very next one is as well. Yep. So complete the timing diagram for this circuit, assuming all Q inputs begin in the low state. Okay, so if we look at our first flip-flop, we see that its input is its own complement. And so whatever Q is, Q bar is the opposite. And so it is on every positive clock cycle going to toggle because it's always going to become what its opposite was. So Q0, this first one, is going to look like this. And then Q1 is going to lag behind by 1 from Q0 because it can't change immediately as Q0 changes because Q0 takes a little bit of time. So it's going to be just like Q0 but lagging behind by 1. And then Q1 is not going to change at all until it first gets a signal, or Q2 is not going to change at all until it first gets a signal that Q1 has changed. So it's going to be lagging behind Q1 by 1. And finally, the last one, Q3, will be lagging 1 behind Q2. Okay, any questions on that? All right, let's take a look at this next one. Now, the past 2 times Dr. Trahan has taught this class, he's had a question very similar to this one on the first homework. I think this was actually from the homework from last time. So it says, for the circuit below, what is the sequence of output values on consecutive clock pulses starting from Q2, so this is Q2 right here, Q2, Q1, Q0 until reaching 0, 0, 0 again. Who did y'all have for Digital Logic 1? Manal, okay. I don't know how she does this because the Dr. Trahan counts 0, 1, 2. Dr. Vedi counts 2, 1, 0. So yeah, it doesn't, I mean, there's not a right way and a wrong way, but you just got to always pay attention. Where is 0, where is 1, where is 2? Okay, so, all right, so we're starting with the output here is 0, and the output here is 0, and the output here is 0. So that is that's the first thing we have, is 0, 0, 0. These are T flip-flops. Now, can you remind me what T flip-flops do?
It toggles. So whatever the input is the opposite.
Almost. So that's the mistake I always make at the beginning of every semester until I remind myself that when the input is 0, it doesn't change, and when the input is 1, it toggles from whatever it was before.
Okay.
So it doesn't toggle the input, it toggles from what it was before.
Right. Okay.
So when the input is 0, it stays the same. When the input is 1, it toggles its output.
Okay.
So when we look at this first flip-flop, we see that its input is 1, and it's just plain 1. It's not attached to any circuit, it's just 1. And so that means its input is always 1, which means every clock cycle it's going to toggle because its input is 1. So it's going to start at 0, and then it'll be 1, and then 0, and then 1, and then 0, and then 1. And I'll just leave it at that for right now. Now the next T flip-flop, we see that its input is also 1. And so it will also toggle from whatever it is. So it would be 1, 0, 1, 0, 1. And then we look at flip-flop 2, and we see that it also has the input of 1, so there must be something different. And we see, though, hey, this is kind of weird. It's going, the output from flip-flop 1 is going into the clock. And so that makes me say, oh, well, let me go back and look at my first two. No, my first two, the clock is attached to the clock, so that's okay. So this last one has the input from, the clock is attached to the output from flip-flop 1. Now, I didn't mention this when I talked about the T flip-flop, but if the clock is 0, it's not going to do anything. And so it can only change on the positive edge of the clock. So it can only change when its clock goes from 0 to 1. Well, when would its clock go from 0 to 1? It would go from 0 to 1 whenever flip-flop 1 went from 0 to 1. So the, quote, positive edge of flip-flop 2 is going to be right here. So it could change here, and it could change here, and it could change here. But it can't change when it's going from 1 to 0. And so, but its input is 1. So if it changes, it's gonna toggle what it was before. So this first time, the clock is going from 0 to 1, so it will toggle. But on the next clock, the next genuine clock cycle, its clock input is going from 1 to 0. Well, that's not a positive edge, so it can't do anything. It can only change at the positive edge of a clock. So it'll stay 1. On the next clock cycle, it'll go from 1 to 0. And then it will stay the same, and the direction said until you get back to 0, 0, 0. Now, you want to be careful with how you write it, because it says Q2, Q1, Q0 equals 0, 0, 0. So, and this was Q2, Q1, Q0. So to write your answer, you would write Q2 first. So it would be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0. I just want to make sure this is... the same as, I had two different versions of this problem. Want to make sure that I've got the same one. Yeah, I do. Okay. Because I had a different one last year. Okay, so those are all the problems that I had set up for today. But if any of you have any questions, I'll be happy to answer questions. And then I said before my Zoom people came in, on Wednesday I'm going to be going over stuff that'll help you with the lab report. But if y'all have any questions, I'm happy to answer questions.
Could you please go over why when Q1 goes from 0 to 1, that for Q2 it goes to 1, and then why when Q1 goes from 1 to 0 it stays at 1?
Yeah, okay, because on this last one, the clock is not really the clock. The clock is the output from Q1. So Q2 can only change when Q1 goes from 0 to 1.
Okay.
And so on the first step right here, Q1 went from 0 to 1, so it could change.
Right.
But on the next one, it went from 1 to 0, so it stayed the same. Because when it can only change on the positive edge of the clock. Okay, other questions? All right then, so if y'all were in circuits 1 last semester, you might have gotten to know me then, but if you weren't, I really appreciate getting questions, and so if you have questions, feel free to email me, and if you ever want to ask me questions in person, you can email me and we can set up an appointment for you to come see me, or if you are an early bird like me, you can come see me early Tuesday or Thursday morning. That's all I have for today. All right, well, thanks for coming. I really appreciate it. I like people to come to my sessions, so thank you. Bye. You're welcome.